Again, this video is on section 3.1. It goes along with homework assignment number 31. Now again, I'm using the notes from your weekly assignments and class notes that are already marked up. I'm not using the blank, I'm using the key. So if you can't read this from the video, go print your notes off. There are some basic rules that we need to know. We're going to be talking about the extremes of a polynomial function. Now the extremes mean what's going on at the ends of the graph. There are 4 situations that we're going to look for. Now we need to always be able to find the leading term. Remember, the leading term is the one with the highest exponent. And once you find the leading term, you're going to be looking at the sign that's in front of it, and then the power of the x value. So, for example, I could have a leading term that starts with a positive and has an x to an even power, or a negative with x to an even power, or a positive with x to an odd power and negative with x to an odd power. Now here's what's going on. If you listen carefully, this is not hard, it's just something you need to pay very close attention to. If I have a positive x to an even power, the sign tells me what's happening at the right end of a graph. Now look down here. If you look at this graph, this is the right end. If you look at this graph, this is the right end. It's what's happening on the right end of the graph. Is it going up or down? So the sign tells me what's happening on the right end. The even or odd tells me if the ends are going in the same direction. Now to me, even indicates that the ends are together. If I have a negative x to an even power, negative says that on the right end the graph's going down. Even says the ends are together, either both up or both down. If I have a positive x to an odd, now positive says the graph is going to end on the right end going up. Odd says the ends are different. Sometimes you'll hear me say split ends, different, opposite, different directions. If it has a negative x to the odd, the negative says the right's going to be down, odd says the ends will be different, which means the left would be up. Now here's a little example from your textbook on what's going on doing just that. Positive x even. Positive says it ends on the right up. Even says they're together, so the left and right are up. Negative says it ends on the right down. The even says they're both down. Positive says it ends on the right up. Odd says the other would be down, down and up. You see what I mean here. Now if you need some help as you go along, pull this sheet and take a look at it. What you're going to be doing is not actually graphing, but matching. And let's go along with this. And I've got a lot of writing. We've got 4 equations. We have 4 graphs that we're trying to match. Number 1, I'm finding first the leading term, which is 2x to the 5th, and the y-intercept is 0, negative 2. Now if you look at all 4 of my equations here, they all have 0, negative 2 as a y-intercept. You look at my 4 graphs, all 4 of these y-intercepts could be at 0, negative 2, so that didn't help me in this one. If I look at 2x to the 5th, I have a positive 2, which says the right end's going to be up. The odd says the ends would be different, which means if the right end is up, the left end has to be down. So I'm looking for a graph such that right end is up, left end is down, and that is A. Alright, look at number B. 2x to the 4th. Now we've already agreed what the y-intercept is. That didn't help us. 2x to the 4th. The positive says the right end is up. Now if you look, that's down, that's up, that's down. Looks like it may have to be this one. The even says they're going in the same direction. Both left and right are up, so it has to be B for number 3. Okay? If I look at C, be very careful here. Negative x to the 4th is the leading term. It's not in the true order. Negative x to the 4th. Negative says the right end is down. The even says the other end will be doing the same, so both ends of the graph will be down. And if you look, here's the graph with both ends turned down. That would be C for number 2. Okay. D, Again, not in the right order. Negative 3x to the 7th is the leading term. Negative says the right must be down. Odd 7 says the other has to be up. So the right end is down, the other end would be up. That would be D. Those just happen to be in the same order when they came to you. I didn't plan that. Alright, now again, let's look at some more matching. Let's look at problem 2 on the next page. If you look at your equation, negative x cubed plus x squared plus x minus 1, my y-intercept is 0, negative 1. Now, process of elimination will get you a long way here. This cannot be negative 1. Mark it out. This could be negative 1. This could not be negative 1. It looks like by just knowing the y-intercept, this is it. Now, let's double check. Negative says the right end is down. Cube says the other end would have to be up. Now I've got that all explained right over here if you need another lesson in that. But no choice. Graph 2 has to be the middle graph. Number 3. We have x to the 4th for a leading term. Now think about that. X to the 4th is positive, so the right end is up. Here's the right. 4th is even, so the other end would be the same. So the left end is up. Both are up, left and right. Now if you look, this one cannot be because they're down. These are both up. These are both up. Now let's look at what else we have to go with there. The y-intercept, there's no number there, so it has to be 0, 0. This one does not go through 0, 0. Therefore we marked it out. This one does go through 0, 0. So number 1 would be my answer. I think we'll have to wait again until another video for the rest.